Okay, we flushed the RPZ valve, now we need to flush the test kit and carry out the tests across from high side into the intermediate zone and then high side water into the downstream zone 3, just to prove that we get a differential across check valve 1, the relief valve opens up at, and also we get a differential across check valve 2. Okay, so what we first need to do is open up the low side, open up the low bleed, allow the air to flush through. Do exactly the same on high side, so open up test top 1, open up the high bleed, allow the water to flush through. Once we're happy we've got all the air and the debris out, we're going to get permission on the customer to shut the downstream isolation valve, which we've got. We're going to close the downstream isolation valve, and we're then going to shut high bleed, low bleed to give us our apparent differential across check valve 1. So nice and gently, we're going to close down. So the reading has now gone up, indicating that the differential gauge is recording. We're now going to shut the low bleed. We're going to allow it to settle down, and then we're going to record this as the apparent differential across check valve 1. We now need to get the relief valve opening. So to get the relief valve to open up, we're now going to use our bypass valves. So our manifold to send high side water into low side, then high side water through the bypass to check that check valve 2 is holding tight. So how we do that, we open up the high side 2 full turns. This is going to allow us to have a feed into the manifold to supply water into each of the zones downstream of check valve 1. So once we're happy it's settled, what we're then going to do is open the low side no more than a quarter of a turn. We're going to get our finger in place ready. As soon as we see the water discharging, we're then going to record what the low valve, relief valve discharge is at. So as soon as we see a drop of water, okay, we're going to close that back down. First drop of water we saw, the relief valve opened up at 16 kPa. Okay, so now what we now need to do is get the check valve 2, so ensure that that is actually holding tight. So how we do that is we need to purge. So we're going to purge the bypass. We're then going to purge test cop 3. We're going to connect the bypass to test cop 3. We're going to open up test cop 3, leaving the bypass valve closed at this time. We're going to reset the gauge by opening up the low bleed. Once we've gone past our differential, we're going to close the low bleed, allow the gauge to settle down, and then we're going to open the bypass up 2 full turns. This is going to allow the high side water to go through the bypass to check that check valve 2 is holding tight. So half, 1, 2, so that's 2 full turns. Exactly the same test as we did before, so all we're doing is looking for any discharge from the relief valve. There's no relief valve discharge coming out, and we want a steady reading. Provided we've got a steady reading, we can capture that. So at the moment we know check valve 2 is held tight, but is that the true reading? So what we need to think about is disc compression. So at the moment high side water doesn't normally go in the downstream zone 3. So what we're pushing potentially is the seating back into the intermediate zone. So where we're trying to take our readings from. So what we now do is open the low bleed, allow the gauge to reset to its high end, close the low bleed back down, allow the gauge to settle, and then we're going to record this as the static differential between upstream zone 1 and the intermediate zone, so high side and low side. Record that, it's in there. Okay, so now what we need to do is get the differential of check valve 2. So how we're going to do that is we're going to take the kit off and move it over one place.